You think you are ready. You think that bag on your shelf, the one stuffed with 50 gadgets, the one that cost you $400 on a tactical website, is going to carry you through the worst night of your life. It will not. Picture the moment the grid actually fails. Not in a movie, in your neighborhood. The street lights die. The refrigerator hum stops. Within hours, the stores are stripped bare, and within a day, the roads are choked with people who never planned for this. You grab your pack, the heavy one, the one with 50 essential items, and you start walking. By the third mile, your shoulders are screaming, and your knees are grinding, and you realize the gear that was supposed to save you is the reason you cannot move fast enough to reach safety. This is the lie the entire survival industry is sold for years. More gear, more comfort, more weight, more confidence. But weight is not safety. Weight is a tax on your speed, your stamina, and your odds. The people who actually study collapse, the engineers, the emergency planners, the search and rescue veterans, they all agree on one thing. What saves you is not volume, it is function. Only 7 tools, chosen with brutal discipline, can carry the weight of a full survival system on your back without breaking your body in the process.
Before naming a single item, you have to understand the principle that decides whether something belongs in your pack at all. Call it the multiplier rule. Every ounce you carry has to earn its place by performing more than one essential job. A single-purpose object is a comfort item from a world that still has supply chains and replacement parts. In a collapsed system, that world is gone. Most people misunderstand this because modern life trains us to specialize. We are used to a drawer full of single-use kitchen tools, a closet full of single-use clothing, a garage full of single-use equipment. That habit of mind is exactly what gets people killed when systems break down. The hidden science here is really a principle from engineering and logistics, the idea that redundancy without versatility is dead weight, while versatility without redundancy is fragility. The optimal survival load sits at the intersection of the two, a small number of tools that each generates several independent capabilities. Historical accounts from disaster zones, from hurricane evacuations to wilderness rescues, repeat the same pattern. Survivors who did well were not the ones with the most equipment, they were the ones who could solve several problems with a handful of objects. This is not a guess, it is a documented pattern across emergency management literature. So as you build your kit, every choice that follows is tested against one question. Does this do at least 3 real jobs? If it does not belong on your back. That is the standard the next 7 items have to meet, and the stakes only escalate from here, because the first failure point in almost every survival emergency happens faster than people expect.
The first thing that kills you is not what you imagine. It is not starvation. It is not dehydration. In cold, wet conditions, a human core temperature can fall past the point of safe recovery in under 2 hours. Your hands lose fine motor control first. Then your judgment degrades. Then you stop making good decisions exactly when you need them most. Most people assume they are covered because they own a lighter or a box of matches. That assumption fails constantly in field conditions. Lighters run out of fuel, and there is no gas station to refill them. Matches absorb moisture despite waterproof packaging, and even when dry, a box only gives you a few dozen attempts. The cheap miniature sparking rods sold in starter kits barely throw a spark when your hands are steady, and your hands will not be steady when it matters. The hidden science is in the material itself. A high-quality ferrocium rod, full-sized rather than a tiny keychain version, can deliver more than 10,000 strikes, producing sparks that burn near 3,000 degrees Fahrenheit. That heat ignites prepared tinder, even when the rod itself is wet, frozen, or being struck with shaking hands, because the chemical reaction does not depend on dry fuel the way a lighter does. Field reports from cold weather survival training consistently show ferro rods outperforming lighters and matches, specifically because mechanical sparking is far less failure-prone than chemical ignition in wet conditions. But the multiplier rule applies here too. A bright shower of sparks at night is visible from a long distance, making the same tool a signal device. The act of building fire also has a measurable psychological effect, lowering panic and restoring a sense of control, which emergency psychologists describe as a key factor in survival decision-making. Filed down, the metal body of the rod can even produce fine shavings useful as emergency tinder. One object, several distinct survival functions. Fire solves the immediate crisis of cold, but a fire alone cannot solve the next problem waiting just behind it, the one that arrives with a much shorter countdown than most people realize. The classic rule of threes states that a person can survive roughly 3 days without water, but that number assumes near total rest in mild conditions. In real physical exertion, dehydration symptoms appear far sooner, often within 24 hours, and they bring impaired judgment exactly when clear thinking is most necessary. Many people now carry a filtered straw device, the kind that removes the vast majority of bacteria and protozoa from natural water sources. These devices work well until they clog with sediment, freeze solid in cold weather, or fail to let you transport water back to a camp or shelter, since most are designed for drinking directly at the source. Chemical purification tablets carry their own limitations, often requiring 30 minutes to neutralize pathogens, leaving a strong aftertaste, and eventually running out with no way to replace them in the field. The far older and more reliable method rests on basic thermodynamics. Heating water to a rolling boil for about 1 minute at sea level destroys essentially all disease-causing organisms, a principle confirmed repeatedly in public health and wilderness medicine literature. This is why a single-wall stainless steel bottle paired with a nesting cup outperforms more expensive filtration gadgets. Single-wall construction allows it to sit directly in coals or over an open flame, something double-wall insulated bottles in plastic containers cannot safely do. The multiplier effect here is substantial. The same bottle that purifies water also functions as a transport container, a cooking pot for the nesting cup, and even a heat source when filled with boiled water and wrapped against the body at night, a technique field medics have long used to manage mild hypothermia. Filled with water, the bottle even adds enough mass to serve as an improvised defensive tool if absolutely necessary. Hydration solves one threat, but the environment itself is constantly working to undo every gain you make, and that threat operates on its own brutal schedule. Exposure does not wait politely for you to finish solving other problems. Wind, rain, and temperature swings can push a wet, poorly sheltered body toward dangerous heat loss in only a handful of hours, regardless of hydration status. Most people default to a tent because it feels like a complete solution, 4 walls and a roof in a compact package. The trouble is that a tent does exactly one job. It cannot be reconfigured, camouflaged, or adapted as conditions change, and a brightly colored tent is visible from a significant distance, signaling to anyone nearby that valuable supplies are close. Zippers fail, poles snap, and once a single-purpose shelter breaks, you are left carrying several pounds of useless material. A heavy-duty tarp in a muted natural tone solves this problem through sheer adaptability. With cordage and 2 anchor points, it becomes an A-frame shelter in minutes. Staked at an angle, it becomes a lean-to that blocks wind while opening toward a fire. With a center hole cut, it becomes a poncho for mobility in heavy rain. Angled correctly, with the corners staked low, it becomes a rain catchment system capable of collecting usable drinking water during a storm. Laid beneath a sleeping area, it becomes insulation against ground moisture, which draws heat from the body far faster than cold air alone, a principle well documented in cold weather survival training. The underlying science involves microclimate control. By blocking wind and reducing airflow, an enclosed tarp shelter can raise the effective temperature inside by 10 to 20 degrees compared to the open air outside, a meaningful swing when the difference is between manageable cold and dangerous heat loss. A tarp can also serve as a signal panel for rescue, a camouflage layer over a hide site, or an improvised stretcher if someone is injured.
Shelter capability is now established, but none of it can be built, repaired, or defended without the next tool, the one survival communities argue about more than any other. The debate over the ideal survival blade has gone on for years. Hatchet against machete, folding knife against fixed blade, multi-tool against dedicated knife, and most of that argument misses the point entirely. A hatchet performs one task extremely well and almost nothing else, while adding unnecessary weight for a single function. A machete excels in dense jungle terrain, but becomes an awkward liability outside that specific environment. A multi-tool offers convenience for small repairs, but cannot handle heavy structural work like splitting wood for shelter components. The tool that actually meets the multiplier standard is a 4 to 5 inch full-tang fixed-blade knife made from carbon steel. Full-tang construction means the blade and handle are forged from one continuous piece of steel, which prevents the knife from breaking at the handle under heavy use, such as batoning through branches. Carbon steel holds a sharper edge than stainless steel and can be resharpened using nothing more than a smooth river stone if necessary, though it does require more maintenance to prevent rust. A blade in this size range is long enough to process firewood and build shelter components, yet short enough to maintain fine control for detailed tasks. Because it has no moving parts, there's no folding mechanism or locking pin that can fail under stress. With this single blade, a person can baton through wood to produce fuel and structural pieces, carve notches and stakes for shelter construction, process any game that is trapped or hunted, and, if absolutely necessary, use it as a last resort defensive tool. Military field manuals and wilderness survival instructors consistently identify a quality fixed blade as the single most relied upon tool in sustained outdoor survival, precisely because of this range of function. A knife alone, however, cannot bind structures together, and that limitation exposes the next critical gap in the system. Cordage seems like a minor detail until you actually need to hang a tarp, secure a trap, or repair torn gear in the field. And this is where most people make a costly assumption. Paracord has become the default choice largely through habit rather than performance. It stretches noticeably when wet, which causes ridge lines and structural lashings to sag exactly when they are under load. It carries a relatively low strength rating for its bulk, and its nylon construction degrades under prolonged ultraviolet exposure. The inner strands, sometimes marketed as bonus fishing line or sewing thread, are thin and slippery, offering little real utility for either task. A stronger and far more proven alternative is braided nylon bank line, the type long used by commercial fishermen and professional trappers who depend on cordage reliability for their livelihood. A common heavier gauge variety carries a test strength well above 300 pounds in a noticeably smaller diameter than paracord, and its construction resists ultraviolet degradation and water absorption far better. Its texture also holds knots significantly more securely, reducing the slippage that plagues smoother paracord. 300 feet of this line, which takes up a fraction of the space, can serve as a tarp ridge line, an actual functional fishing line capable of landing real fish, a snare or trap line, a gear repair thread for torn packs or clothing, and an emergency replacement for broken shoelaces or pack straps. Outdoor survival instructors who train search and rescue volunteers consistently favor bank line over paracord, specifically because of its superior strength-to-weight ratio and knot retention. With cordage solved, the entire system you have built so far still faces one constant, quiet threat that almost nobody plans for properly. Moisture is the silent saboteur of every survival system, and it is relentless. It does not announce itself the way fire or thirst does. It simply accumulates in rain that will not stop, in condensation building inside a closed pack overnight, in a river crossing that soaks everything you own in seconds. Once gear gets wet, tinder will not light. Stored food spoils faster, and dry clothing becomes a heavy, useless burden. The physiological cost is severe, since wet clothing strips heat from the body at a dramatically faster rate than dry insulation, a well-established principle in cold weather medicine. Most people pack a single trash bag as an afterthought and assume that is sufficient protection, but it almost never is. The actual solution is remarkably simple and remarkably underrated: a handful of heavy-duty 55-gallon contractor bags. Lined inside a backpack before loading gear, a contractor bag transforms an entire pack into a waterproof container, protecting clothing, tinder, and food simultaneously. With a head hole and armholes cut into it, the same bag becomes an improvised rain poncho. It can hold many gallons of water hauled from a stream back to a camp for drinking, cooking, or cleaning. Buried in a hole with vegetation beneath it and another bag stretched over the top, it becomes a basic solar still capable of condensing drinkable moisture from plant material, a technique documented in wilderness survival manuals for decades. Filled with leaves or soft plant material, it becomes an improvised sleeping pad but insulates against heat loss into the ground. Laid flat in an open area or hung in a visible spot, its bright color can help searchers spot a stranded person from the air. For an item that weighs only a few ounces, this level of layered utility is difficult to match with almost anything else in a typical pack. Yet even with every one of these systems working together, equipment failure remains inevitable, and that inevitability defines the final tool in this framework. Every piece of gear eventually fails. Tarps tear along stress points, bottle seals wear thin, boot soles separate from constant impact, and pack straps fray under repeated load. In a collapsed system, broken gear either gets repaired in the field, or it becomes permanent dead weight. The single most effective answer to this problem is also one of the least glamorous items a person can carry: a flat-wrapped length of high-quality duct tape, typically 20 to 30 feet, rolled around a spent gift card or similar flat object rather than carry it as a bulky full roll. Despite its plain reputation, duct tape performs an unusually wide range of critical functions. It can form butterfly closures to help hold a wound together, stabilize a sprained joint with improvised wrapping, and cover blister-prone areas before they become debilitating. It can patch a torn tarp on both sides to restore a waterproof seal, repair a split pack seam, or wrap a failing boot sole enough to keep someone walking. Rolled into a small fluffed ball, it ignites readily from a ferro rod spark because of its petroleum-based adhesive, giving a reliable backup fire starter that burns long enough to catch damp kindling, a property well known among wilderness instructors. Twisted into strands, it can function as emergency cordage in a pinch, and it can splint a support pole for a tarp shelter. The material science behind its reliability is straightforward. A pressure-sensitive adhesive bonded to a flexible cloth backing allows it to stick to irregular surfaces, remain flexible in cold temperatures, and resist losing adhesion even when damp, which is why it remains a staple recommendation among emergency responders and long-distance backcountry travelers alike. Step back and look at the full system now in place. Fire from a quality ferro rod, water purification and storage from a single-wall steel bottle, adaptive shelter from a tarp, cutting, carving, and defense from one full-tang fixed blade, strong weather-resistant cordage from bankline, comprehensive waterproofing from contractor bags, and field repair capability from a small roll of duct tape. None of these items are flashy, none of them would look impressive laid out for a camera, but each one performs several distinct survival functions at once, which is precisely why they matter more than 50 scattered single-purpose gadgets ever could. The pattern that emerges across emergency management research, wilderness medicine, and historical accounts of disaster survival is consistent. Systems fail and collapse, not individual pieces of gear. And the people who endure are the ones who understood how a small number of versatile tools could be chained together to solve cascading problems. The real lesson buried underneath all of this is that equipment alone never saves anyone. Knowledge does. A person who has actually practiced building a fire in wet conditions, who has pitched a tarp shelter before needing it for real, who has boiled water under pressure and repaired gear with tape in the dark, carries something no amount of purchased equipment can replace. That knowledge becomes instinct only through repetition, long before any crisis arrives. The tools in this list are simply the physical extensions of that practiced skill, multipliers for a mind that already knows what to do with them. Anyone can buy 7 items. Far fewer people will actually train with them until the actions become automatic, and that gap, more than any gear list, is what quietly decides who manages a crisis and who is overwhelmed by it.